Well, hi, everybody. Thanks for joining today for our training session on the recently updated EQB Climate Calculator. My name is Emily Gala. I'm a director at ICF and led the development of this calculator. Today, with the help of a few of my colleagues, we'll be highlighting recent updates and new features of the calculator. And before we begin, I'll note that this training is being recorded and will be made available online for future reference. So in terms of an agenda, today we'll start by providing some background on the calculator, walk through recent updates, and then give a demonstration of the new features. And then we'll have some time at the end as well for Q&A. So starting with some background. So the initial version of the climate calculator was completed and released in July of last year. Earlier this month, a new version was released and posted online at EQB's Climate Assessments website. You can also find other materials about the calculator online, including a user manual and report that documents the calculator's methods and assumptions. And both of those were also updated as part of this recent release. Prior to the release of the calculator last year, we held a series of trainings on the calculator, and these are available online as well. So those trainings included information on settings, structure, navigation, and formatting of the calculator, key features including data validation, completeness, checker icons, and default buttons, data inputs and outputs, an overview of the mitigation and adaptation modules, and finally, we highlighted some limitations of the calculator. So I encourage anyone who has not used the calculator before to check out those resources, since they provide more comprehensive information on the calculator than we'll be covering in today's training. So before we dive into the details about the recent changes, I'll provide just some brief information on the purpose and scope of the calculator for anyone who doesn't have that context. So the climate calculator was developed to help project developers and regulatory government units assess the greenhouse gas emissions impact of potential projects in Minnesota. It also identifies mitigation and adaptation strategies, and specifically can assist in answering the EAW items that relate to greenhouse gas emissions, mitigation, and adaptation. I will note that the use of the calculator to complete the EAW is not a requirement. And in terms of scope, the calculator aims to assess the full greenhouse gas impact across both the construction and operational phases of a project. And this includes looking at both upstream and downstream impacts across 18 defined emission sources. As you can see in the diagram shown, the calculator quantifies emissions from 6 potential sources during the construction phase and 12 potential sources during the operational phase. Most of these emissions result from activities that occur on the project site. So for example, burning diesel to operate construction equipment or clearing land to build a new housing development. However, other activities occur upstream or downstream of a project. So this includes the transportation of materials or people to the project site, emissions from the production and transportation of fuel or electricity that is then consumed on site, and the transportation and treatment of waste that is generated by the project but treated offsite. The calculator covers key emission sources that were prioritized for inclusion based on a variety of factors, such as the expected applicability across projects and feasibility to clearly define and quantify. Therefore, we recognize that depending on your project, other sources may apply, and that developers should not hesitate to supplement the results of the calculator with additional information. But for today, we're going to be focusing really on the calculator updates that have been included as part of this version 1.2. So the table on the slide here highlights these changes. The first three updates related to land use change, wastewater treatment, and HFC leakage involved further tailoring of existing calculations and assumptions to improve the accuracy of the results. The next two updates related to construction equipment and building energy consumption involved adding alternate calculation options to the calculator to give users more flexibility in what data they provide. And then the final update involved adding the capability to quantify reductions from select mitigation measures. And I'll use the next slides to walk through each of these updates in more detail. So starting with the land use calculations, the key change we made was to further tailor the carbon stock assumptions for wetlands by soil type. So previously, the wetland carbon stock assumptions were only disaggregated for forest and non-forested lands. But now users can also tailor their assumptions for peatland and mineral soils. And so you can see these new assumptions in the Assumptions tab within the calculator. Another improvement we made was to the wastewater treatment calculations. First, we added a drop-down in the user input tab that allows users to select the system type and then tailors the emission factors based on that selection. We also added an equation to account for direct nitrous oxide emissions, which were previously not included in the calculations. And you can see this equation and the resulting emissions on the Operations tab of the tool. And then finally, in terms of calculation improvements, we updated the HFC leakage calculations to give users the option to select the
Emily, you're muted.
Sorry about that. All right, did it just mute me? Yes, okay. Yeah. So the HFC leakage updates that we made, so we added an option to select the refrigerant type in the user inputs tab. And this was previously a non-editable default assumption in the calculator. We also updated the default assumptions and removed some of the equipment types that were previously assumed to use HFCs. So these changes better align with recent trends and regulations that now prohibit the use of HFCs in certain equipment types. The next two slides highlight new flexibilities that we've added into the calculator. So first, the construction equipment. We've added a new approach that allows users to enter anticipated fuel consumption rather than information on equipment use. So users will need to select which calculation approach they want to use in the User Inputs tab, and then the data input requirements will adjust accordingly. So for the building energy consumption, We added a similar flexibility that allows users to directly enter anticipated energy consumption rather than providing data on building energy intensity. So again, users will need to select which calculation approach they want to use in the user inputs tab, and then the data input requirements adjust accordingly. So the final enhancement we made to the calculator as part of this recent release is the addition of mitigation measure quantification. So users will note that we've added a new tab called Quantified Reductions to the calculator, where select measures, if they're applicable to your project, can be quantified. The calculations build off both the data and quantification methods that are already embedded in the tool. And users will note as you fill in data in both the project, background, and user inputs tab that some inputs are highlighted with a star icon. And so this star icon indicates that the data input is potentially used in the quantified reductions. So for example, on the slide, you can see the data input requirements for calculating emissions from employee commuting. If users indicate that some employees carpool to work, then you select the implementation of a rideshare program as one of the mitigation measures. The calculator will then use the data entered into the user inputs tab to quantify reductions from that program. So the quantified reductions are contingent on which measures are selected in the mitigation tab. We've added a new column to the table in the mitigation tab that highlights which measures are quantifiable in the calculator. We've also added a new button that automatically selects measures that are deemed to be applicable based on the data entered. And then otherwise, this tab contains the same information that was available in the prior versions of the calculator. So all the mitigation strategies that were there before are still here, just not all of them are quantifiable. So if you do select measures that are quantifiable and applicable to your project, the Quantified Reductions tab then shows these results. And as I mentioned, only select measures are currently quantifiable in the tool, and these are listed in that table at the top. In most cases, no additional data inputs are required to quantify reductions beyond what you've already entered in the tool. However, there are a few measures that require additional information in order to quantify results, and those are highlighted by the yellow cells in this tab. You can scroll down the tab to see data inputs used to quantify reductions for each measure. And then the results by measure are also summarized at the top in the table. Users will have the option to generate a PDF output of the tab, which can be appended to their EAW if desired. And now I'm going to turn it over to my colleague, Sophie, to walk you through a demonstration of the new features.
Thank you, Emily. I'm just going to pull up the calculator, and like she said, I'm going to walk through an example of these new features. All right. So in the previous training, we walked through each tab of the calculator in depth, including how to set up Excel macro settings, general features and functionality of the calculator, and each step of the tool from user inputs to results. For the purposes of this demo, I'm only going to focus on the enhancements that were added to version 1.2 of the calculator. But like Emily said, users may watch the previous training session recording for more details on how to use the other tabs of the calculator. The steps for using the calculator and instructions on macro settings can be found on this user guide tab. In this version, we've also added icons to the legend, including that star icon that was added to indicate inputs used for potential mitigation measure quantification. The table of contents on this tab also now includes the new quantified reductions tab and its description. For the purposes of this demo, I've already added some inputs to the yellow cells on the project background tab, and I've applied defaults for construction durations and applicable emission sources. However, I'll note that I've changed the default applicability of treatment of wastewater on site to yes in order to demonstrate new functionality for this source, which I'll show later on. On this tab, user inputs are shaded in yellow, with non-applicable fields shaded in gray with black dashed lines. Gray checkers also appear by these inputs since they are not needed, and we'll see a few examples of these further down the tab. As a reminder, users should populate using the best available data or assumptions, but remember that in this case, I'm not using any real data. I've applied dummy data or defaults to all sources, and I will focus only on the changes made from the previous version, as I noted earlier. So to start, for employee commuting, as noted by the star icons next to the inputs table, employee commute inputs are used to quantify reductions from mitigation measures. To show reductions from the implementation of a rideshare program, we'll change these defaults to 50% carpool and 50% single occupancy vehicles. And I'll change the rest of these to 0 so that the sum is 100%. As Emily noted earlier, there are now 2 approach options for construction equipment. Users must first select an approach using the dropdown. So I'll select the new fuel consumption approach for this example. You'll see now the inputs for approach 1 are grayed out now that I've made a selection. And approach 2 requires inputs for total amount of fuel by fuel type consumed by all construction equipment during the construction phase of the project. Since there are no defaults for this option, I've input some dummy data for total consumption by fuel type in the units displayed. For land use change during the construction phase, there are now 4 new land use types for wetlands. So for this example, we'll assume that pre-construction, all of the land was wetlands, mineral soil, forested. And post-construction, we'll assume 2 acres stay as this land type, 3 acres become lawn or landscaping, and the remaining 15 acres become impervious surface. Scroll through the next sources, which have not changed from the previous version. Similar to construction equipment, users can now select one of 2 approaches for building energy construction as well. So I'll use the new fuel consumption approach here again, which I've selected from the dropdown. And you'll see that with that selected, the approach 1 inputs table grays out. For approach 2, users must enter the total amount of energy consumed annually by fuel type in the units displayed. Since there are no defaults for this approach either, I've entered some dummy data for this approach as well. The next few sources were indicated as not applicable on the project background tab and are grayed out here as they do not require inputs. So I'll scroll through these to get to the next input section for HFC leakage. Here, I've applied defaults for % of area utilizing air conditioning or refrigerants, which assumes that all of the building area utilizes air conditioning and/or refrigeration equipment. In this version of the calculator, there is now the option to either use the default HFC types or to select another lower GWP HFC for each building type. So for residential buildings, I'll select a different option and we'll go with non-HFC. For commercial buildings, I'll change from the default to R454A. And for industrial buildings, I'll keep the default as is. I'll also note that if you're unsure what the GWPs are for each HFC, these are also listed in the Constants tab at the end. I'll now go to the next input section, which was updated, which is treatment of waste on site. This version now includes a new user input for waste treatment system type, which tailors the emission factor used in the calculations. For this example, I'm assuming that there is treatment of wastewater on site, as I indicated on the project background tab earlier, and I've put 200 people served in septic system as the wastewater treatment type. Lastly, I'm also going to assume that on-site wastewater treatment is only for municipal, so I've left the second input table for industrial wastewater blank. For treatment of waste off-site, I'm using default waste generation rates, and I put 100 for number of households and 20 for number of commercial employees. You'll also see that there are stars next to this second input table for waste treatment practices, indicating that these inputs are used for mitigation measure quantification. So for this example, I'll assume that we're implementing a recycling program, and I'll change the defaults to 15% recycled, 0% composted, 20% landfilled, and 65% combusted to get my total to equal 100% to fit the data validation requirements. And with that, there are no more inputs needed for my example, so I'll return to the top of the tab and move on to the next steps. I'll skip over this tab as it's discussed in detail in the previous training, and I'll jump to the construction tab. I won't go into much detail in this tab either, but I will quickly show the new sections added that calculates emissions based on selected approach. So I'll navigate to construction equipment using the green navigation button, which takes me to this section. Here you can see that the calculation tables for approach 1 are grayed out at the top, and a new approach 2 section that calculates emissions based on fuel consumption inputs that I provided earlier is shown here at the bottom. Otherwise, there are no new changes to this tab, so I'll move on to the operations tab. Similarly, I won't go into much detail here, but I'll point out what has changed in this version. So for building energy consumption, the calculations themselves don't change, but values pulled into these rows are now dependent on the approach and inputs that I provided earlier. So in this case, the top tables are grayed out since we are following the second approach, which directly pulls energy consumption values from the user inputs tab, rather than calculating energy consumption from energy intensity values input under approach 1. The next section with updates is treatment of wastewater on site, so I'll navigate there with the green button. For this section, a new calculation row was added to account for direct nitrous oxide emissions, as Emily pointed out previously in the slides, and that's shown right here. Otherwise, there are no other changes to this tab, so I'll quickly pass through the results and the charts to get to the updates to the mitigation tab. This tab identifies potential mitigation measures categorized by the expected source of emission reductions. Like Emily mentioned, select mitigation measures are also now available for quantification and are designated in column F, titled Quantifiable, which was added to this version of the calculator. We can click the Select Applicable Quantifiable Measures button to first select measures that are deemed applicable based on entered user inputs. So, for example, under construction equipment, the measure to use renewable diesel is applicable and quantifiable since I've input renewable diesel consumption under approach 2 for construction equipment on the user inputs tab. However, I'll note that you do not have to select these measures that are applicable. This option is just provided to help narrow down measures that the tool allows users to quantify. You can also select other measures that are not quantifiable in the tool, noting that these just won't be shown on the following tab. So for this example, let's also select yes for using sustainable building materials. Now I can filter column B to only those selected as yes. And you'll see that the table is now filtered to just the measures I've selected. Now that I've selected my measures to quantify and implement, we'll go to the new Quantified Reductions tab. This new tab quantifies emissions reductions from the measures that we've just selected on the previous tab. The summary table at top displays measure not selected for those not selected to be quantified. Reductions are quantified based on data entered in the project background and user inputs tabs. And in some cases, additional data inputs are needed, as noted in this first row of the summary table where it says data input required in red. So scrolling down, we'll enter inputs for those that are needed, which in this case only includes the measure to develop a rideshare program for construction contractors. I'll note that this input cannot exceed the % of commuters using alternate modes of transportation, as I've entered in the user inputs tab. If this input does exceed, a red pop-up message will appear. So for example, if I put 60%, the pop-up message is shown in red to the right. So I'll enter 50% instead of employees participating in a rideshare program to the yellow input cell in order to fit the input requirements. As noted in the summary table, no other inputs are needed for the selected measures. But I'll go through a few examples of quantified measures. So scrolling down to using renewable diesel and construction equipment. These values are pre-populated using the inputs I've already provided in the tool. Pre-populated values pull from a hidden mitigation calculations tab, which follows the same methodology and formulas that are used in the green calculations tabs for the project results. In this example, the mitigation scenario uses the renewable diesel consumption that I've input on the user inputs tab and compares to a baseline scenario, which assumes that all fuel consumed is diesel. Emissions mitigated under this measure quantified the avoided diesel relative to what I entered on the user inputs tab. So in this case, 904,498 kilograms of CO2 equivalent are mitigated for this measure. Scrolling through, you'll see that measures not selected are grayed out, and each has a return to top button available for easy navigation throughout this tab. As another example, expand urban tree planting is also shown since I input 100 new trees planted during this project on the user inputs tab. In this case, the baseline scenario assumes no new trees are planted, and in the mitigation scenario, it assumes the 100 new trees planted as I input in the user inputs tab. And the calculations follow the same methods as shown in the earlier green calculations tabs. So for this example, there's a net carbon stock of 182 kilograms of CO2 equivalent for this mitigation measure. Lastly, I will show the measure to use alternate refrigerants instead of high GWP refrigerants. In this case, the baseline scenario assumes that the default HFCs are used for each building type. And the mitigation scenario assumes the alternative refrigerants be selected on the user inputs tab. So in this case, the non-HFC selected for residential buildings has a GWP of 0 compared to the default of 466. And the alternative HFC selected for commercial buildings has a GWP of 237 compared to the default of 466. Following the same formulas as used on the operational phase calculations, this results in about 3.5 million kilograms of CO2 equivalent mitigated under this measure. I'll now return to the top so you can see the baseline emissions, mitigation emissions, and total mitigated emissions by measure and as a total in this top table. In this case, just over 5,000 metric tons of CO2 equivalent were mitigated by these selected mitigation measures. The unit displayed in the summary table will also match the unit selected on the project background tab, which is converted from the kilograms of CO2 equivalent values that are calculated for each quantified measure below. Also note that you can generate a PDF of this tab, as is the case on the mitigation and adaptation tabs, by selecting this Generate PDF button. Details on these calculations and the comparisons between the baseline and mitigation scenarios are documented in the PDF, and these are also provided in the report and user guide on the EQB website. Moving on, this tab identifies potential adaptation strategies, which are mapped to a defined list of climate trends and project characteristics. I'm not going to go into detail on this tab as it was covered in the previous training session. So I'll move on to the Assumptions tab, which summarizes the assumptions used to calculate the construction and operation emissions shown on previous tabs. If you scroll through, you can see each of the assumptions used for each emission source, which are ultimately pulled into the defaults and calculations. For example, though, I'll scroll down and highlight this table. Under municipal wastewater, you'll see the new wastewater system specific emission factors displayed starting in row 302. Lastly, the Constants tab summarizes the constants used to calculate the construction and operation emissions shown on previous tabs. This includes heat contents for different fuel types, conversion factors, GWPs, and equivalency factors. So as I noted earlier, going over the HFC leakage inputs, the GWPs for each HFC option are shown in the GWP table of this tab. And with that, we now have some time for Q&A.
Great. Thank you, Sophie. And we do have time now reserved. If anybody has any questions, you can either raise your hand or come off mute, put something in the chat. And then, of course, if you don't have any questions at this moment, we certainly encourage you to reach out to Steph in the future if you do have questions using the calculator, either for these new recent changes or, of course, just for its general use.